Today we're going to be looking at characteristics of quadratic functions. As you can see, this touches on a lot of state standards. All right. For your success criteria to be successful today in this lesson, you need to be able to use properties of parabolas to graph quadratic functions. You need to be able to identify characteristics of quadratic functions and their graphs. You need to be able to use characteristics of quadratic functions to solve real-life problems. So again, what this does, the success criteria, takes the state standards and then just rewords it a little simpler for what we're looking at, and we are looking at quadratic functions. So you need to be able to use, graph, identify, use, and solve, everything to do basically with quadratic functions. All right, there are several important vocabulary words today. Make sure these are in your notes. Please copy these in your notes. So the axis of symmetry is a line that divides a parabola into mirror images and passes through the vertex. Standard form of a quadratic function can be written as f of x equals ax squared plus bx plus c, where a is not equal to 0. Your minimum value for a quadratic function, the y-coordinate of the vertex, is the minimum value when a is greater than 0. Your maximum value, very similar, the quadratic function. For a quadratic function, f of x equals ax squared plus bx plus c, the y-coordinate of the vertex is the minimum when a is less than 0. So when a is negative, you have a minimum because the parabola is upside down. You have a maximum when a is greater than 0, which means a is positive. You have a U-shaped graph called a parabola, so it would be a minimum value. So that's the difference between your minimum and maximum. Intercept form. When the graph of a quadratic function has at least one x-intercept, the function can be written in intercept form. That's similar to f of x equals a times x minus p times x minus q, where a is not equal to 0. Again, to be quadratic, a cannot be 0. All right, and p and q in this case would be whatever your x-intercepts are. Example 1 says using symmetry to graph a quadratic function. All right, remember you have an axis of symmetry when we have a quadratic equation, and it goes through the vertex. If you remember, this is vertex form. Let's write that up here. Y equals a times x minus h squared plus k. This is your vertex form. All right, so we can identify a few things. We have a equals -2. All right, when a is negative, that means it's upside down. That means this graph will have a maximum value. So that's good to know. All right, we also know that h, so we got x minus h as our equation. Since this is plus, we know that that's minus a -3. So h would be -3 and k would be 4. So we can identify our a, our h, and a k. So we know that our vertex is -3, 4. We can go ahead and graph that point. So we can go over 1, 2, 3, 1, 2, 3, 4. And put a point there. All right, so we did label our vertex. We also can label our axis of symmetry. Our axis of symmetry goes through the x value of the vertex. So our axis of symmetry would be -3. All right, so we have labeled that. Now we want to graph. So we know the vertex. Now we need to choose a couple points to plug in on either side of the vertex, okay? So we know that we have a point at -4. So let's choose, say, -2. So this is similar to the table of values that we've been making, but this time we're just going to choose 2 because we know the axis of symmetry goes through the vertex and we can reflect points to the other side. So let's say let x be -2. And if I let x be -2, that means I have to plug it in and find y. So f of x is our y. So f of x equals -2 times -2 plus 3 squared plus 4. So all I did was plug it in for x in my original equation here. You have to do order of operations, so you have to work inside the parentheses first. So I'm going to have -2 plus 3 is 1. And then I have to square it because exponents come before multiplication. So 1 squared is just 1. And then -2 times 1 is -2. -2 plus 4 is 2. So when x is -2, y is 2. So -2, 2 is another point on our graph. So we can go over -2 and up 2, and we have a point here. Now we know the axis of symmetry comes down through the vertex, so we can go over and also reflect that point across the axis of symmetry and go ahead and put that reflection point there as well. All right, we can go ahead and graph a parabola using those 2 points, but we can also, it doesn't hurt to say let x be one more point. All right, let's say let x be 0. So let x be 0. That's an easy number to plug in. So f of x equals -2. We're going to plug in 0 plus 3 squared plus 4. So f of x equals -2. 3 squared is 9 plus 4. That's going to be -2 times 9 is -18 plus 4. -18 plus 4 is -14. So 0 and -14 is another point. All right, so I think this goes by 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It does. So I chose a point that's going to make this go off the graph here, off the graph paper. So I'm just going to graph it with the 3 points that I have and see if we can make this work. All right, so I'm going to graph the vertex. And again, it would continue down and it would hit at 0, -14, somewhere down here, and then you could reflect that point over the axis of symmetry and graph that point as well. Example 2 is graphing a quadratic function in standard form. Graph f of x equals 3x squared minus 6x plus 1. Label your vertex and your axis of symmetry. All right, so you can go from vertex form to standard form by multiplying out the binomial. So if we look at the previous example, if we square the binomial, multiply by -2, and then add 4, if we multiply that out, expand it, and simplify it, we would have it in standard form. All right, to graph in standard form is a little bit different. Again, this is review from Algebra 1, but we need to make sure that we understand this and how to graph quadratic equations in different forms. All right, so properties of a quadratic formula. You can see that the parabola opens up when a is positive or greater than 0, and it goes down when a is less than 0 or negative. The graph is narrower than the graph of f of x when the absolute value of a is greater than 1, and wider when it's less than 1. Okay, so we did transformations in the first section, so this is just kind of talking about that a little bit as well. The axis of symmetry is x equals -b over 2a, and the vertex is -b over 2a, and then once you plug this value in and you solve for y, that would be your vertex. So this is just your x and y. This is how you get your x and y, your vertex. The y-intercept is c. So whatever this constant value is, that's your y-intercept. So the point 0, c is on the parabola. All right, so you already know that 1 is your y-intercept. how do we find our vertex? We do negative b over 2a. So let's go ahead and start looking for our vertex. So first, identify what a, b, and c are. A is 3. That's your quadratic term. B is your linear term, negative 6. And C is 1, your constant term. All right, to find your vertex, you got to do x equals negative b over 2a. All right, so we know that b is negative 6, so we're going to have negative 6 over 2 times 3. So negative makes that a positive 6 over 6 is 1. So our x value of our vertex is 1. So we can, I'm going to write this up here so we save a little space. So our vertex is 1 something. Now, how do we find the y value? Well, this tells us to take and plug that number into our function. Okay, so plug 1 in right here. You can always find y by plugging x in. So f of x equals 3 times 1 squared minus 6 times 1 plus 1. All right, so we're going to have 1 squared is 1. 1 times 3 is 3. This is negative 6 plus 1. So that would be negative 3. Negative 3 plus 1 is negative 2. So negative 2 is our y value of our vertex. All right, so we can go ahead and graph that point. So we're going to go 1, negative 2. And we know that the axis of symmetry is an imaginary line that runs right through that, cuts that parabola in half. We also know it has a y-intercept of 1, so 0, 1. And we know we can reflect that point across the axis of symmetry to get another point. All right, it only takes 3 points to graph. It's nice to have more, but we can graph with 3 points here. So we have graphed f of x. We need to label the vertex and the axis of symmetry. All right, so let's see. The vertex is 1, negative 2, and that is right there. And the axis of symmetry, let's change colors here. The axis of symmetry is this line that goes down through the vertex. And that's going to be x equals 1. So that's your axis of symmetry. And that's how you graph an equation in standard form. Make sure you look at the study tip over here. It says, notice you can rewrite the quadratic function in example 2 in vertex form because A has the same meaning in vertex form and standard form. All right, so just like what I said before, you could rewrite that. You already know what A is. Once you find the vertex, you could write that in vertex form very quickly. So A is 3. Your vertex is 1, negative 2. So they plug that into vertex form. So this equation is equivalent to this equation here. So standard form, vertex form, two different equations that represent the same function.